Logically, the next thing they're going to want you to do is go from rads to degrees. Hey, this is so exciting. And they give you a negative because that's fun. So we're going to go backwards, which you've already been trained to do. And we're just going to roughly sketch it in where it belongs. The most important thing is to have it in the right quadrant. It doesn't have to be perfectly exact. So if it's 5/7, I know it's going backwards, that takes care of the negative. 5/7 is a little bit past half, so I'm just going to go like that-ish. And so that would be my negative 5/7 pi radians. So I'm going to expect that my degree, when I figure it out, is going to be between 180 and 270. So then I look at my conversion factors, and I want it in degrees, so I want degrees to end up being on top. I obviously don't have that right now, so I have to multiply by something that has degrees on top. So if I look, 1 radian, this is supposed to be radians, so one of these is equal to 180 degrees over pi. So I'm going to go multiply that by 180 degrees over pi. Remember that these are radians in here. I always forget to write it. Is going to get rid of that, and I'm going to be left with degrees. So, and in this one, it actually says determine it to the nearest tenth of a degree. So we're going to actually, as soon as they say determine it to the nearest tenth of a degree, they actually want you to solve it. So we're going to go through and simplify it as much as we can first. So I've got a pi here and a pi here. Those cancel out. Now I've got negative 5 times 180 over 7. So in my calculator, I don't have to worry about pi because I've canceled it. And what I have to do is remember how to multiply. It's hard to do something and talk at the same time, I've discovered. So when I write this in, I get negative 128.6 degrees. And it's said to the nearest tenth of a degree, so I've rounded it off to that and called it good. Now, when I look at my diagram here, this is negative 90 degrees. So for it to go past 90 degrees, but only a certain amount, not a huge amount, and certainly not nearly to 180, then it makes sense that this amount of radians would equal this amount of degrees. So probably did it right.